This is a magic square. While it may look very normal at first sight, it actually has a lot of interesting attributes. Every single row, column, and diagonal share the same sum. Take a moment to look at it. You'll notice that every single row, column, or diagonal has a sum of 34. In the case of a 4x4 magic square, any 2 points that create a reflectional line of symmetry has a sum of 17. This is true with any magic square. For example, any pair of points that creates a reflectional line of symmetry on this 3x3 magic square share a sum of 10. You'll also notice that if you split a 4x4 magic square into 4 quadrants, each of these quadrants has a sum of 34 in this case. For example, 9, 6, 4, and 15 has a sum of 34. Basically, a magic square is a square array of numbers consisting of distinct positive integers 1 through n squared, arranged so that the sum of n numbers in any horizontal, vertical, or diagonal line is always the same number. This common sum is called the magic constant. It can be represented in this equation. It represents the magic constant as m of n. This expression shows the sum of all numbers divided by n, the number of rows or columns. This expression shows the total of all numbers as the average of all of the numbers times the number of numbers divided by n to get the magic constant. Legend says magic squares originated from China and were first mentioned from a manuscript from the time of Emperor Yu around 2200 BC. A Chinese myth claimed that while the Chinese emperor was walking along the Yellow River, he noticed a tortoise with a unique diagram on its shell. The emperor decided to call the unusual numerical pattern Lo Shu. The earliest magic square on record, however, appeared in the 1st century book Dai Dai Li Ji. Magic squares most likely traveled from China to India, then to Arab countries. From the Arab countries, magic squares journeyed to Europe, then to Japan. The oldest magic square of order 4 was found inscribed in Khajuraho, India, dating to the 11th or 12th century. The magic square is also known as the diabolic or pan-magic square, where in addition to the rows, columns, and diagonals, the broken diagonals also have the same sum. Furthermore, Benjamin Franklin played with the construction of magic squares in 1736 to 1737 when he was the clerk of the Pennsylvania Assembly.
Now let's use our knowledge to solve this 3x3 magic square puzzle like this one.
We can use basic algebraic equations to solve this puzzle.
Because the sum of the top row is 15, all the rest of the columns and rows and diagonals have to be 15. Because this column equals 14, we know that the missing square is 15 minus 14, which is 1. Now the sum of this column is 15. Because this diagonal sum equals 7, the remaining square is 8. Now, like the other column, the sum is 15. Because the sum of this row is 9, the remaining square is 6. Likewise, repeat the steps for the other two numbers. This is how you solve the magic square puzzle.
Now we will show you a new cool trick.
Hey Ian, give me a number from between 21 to 65.
64.
64. Ian, be quiet. Give me a number between 21 and 65.
Or 21.
So how did we do this? Pretty simple. Just use this magic square that is already written out for you. This works because if you add up all the rows, columns, and diagonals using the variable n, you all get the same sum. Therefore, if you plug in any value for n, then it'll work. In conclusion, a magic square is a square with all rows, columns, and diagonals that share a same sum, called the magic constant. It originated as far back as 2200 BC.